Hello friends, so welcome in the new video. So as I told you in last video that in next video I will going to interface IoT device with our water quality monitoring system. So here you can see the block diagram because as our system become more and more complex, to explain you I'm just using this type of simpler block diagram. Okay, and if you follow my last 3 to 4 videos, then you must know that we have completed this much, right? In fact, this much UART also. Okay, this part we have already completed. So initially I will interface TDS sensor, then turbidity sensor, then pH sensor, then we have displayed this information on LCD. Then we have also developed design data logger, so data stored on this SD card. Okay, along with this, we have also used RTC module, right? UART module, everything. Now, in this video, just going to add one another module called ESP32. It's an IoT device. Okay, and the different from the last setup is this UART. So initially, this UART was onboard, right? Onboard UART. So simply you have to connect your board with the laptop and just open the terminal and you can see the video that see the values. But this time I'm using separate UART, right? On different pins because now I have to provide the UART data to ESP32. So I'm using jumper wire. So instead of our onboard UART pin, I just selected two other external pin that I will show you in the circuit diagram or in the demo. And I will not change anything in our program. Program will be same as it is, right? But the thing is that I'm going to write the code of ESP32, okay? And here ESP32 will receive the serial data, will extract the information from that serial message, and it will provide that information over the internet, right? So it will simply pass that information through web page, and anybody using that the IP address of this device can access that web page, right? It could be from your laptop or tablet or a mobile, right? And you can simply access that web page and you will have the real time data over the internet, right? So our code will remain same. I'm just adding another module. So STM side, what I've just changed that I'm just demonstrating you. Here you can see the code is same. I'm not changing anything. I'm just changing these two pins. So instead of our last pin was which was a PD8 and PD, right? These are in onboard this UART, right? If you know the Nucleo 144 board, then you must know that this PD8 and PD9 are onboard UART, right? You can see this is UART3. 1 minute. Let me verify it. Yes, this is UART RX, PD8 and PD9, right? But now I have to connect jumper wire. So that's why I'm just change this from PD8, PD9 to PB10, PB11. Our UART will remain same. It's a UART3, right? So this is also one lesson that in on Nucleo 144 board we have multiplexed pin, right? So you can see UART3 is same. I'm just changing the pin, okay, and just recompile the code and upload it on my board. That's it. So nothing is new from the code side. I just change the connection. That's it. Now let us open the Arduino code. Okay. So here in Arduino you can see uh, we have this simple Arduino code, right? So in for ESP32 you have to first of all install required driver and all. So I'm not going much deeper in this code, right? Anyway, I will cover this in another series of ESP32, but still for this video, I just explain you the main part of the code. So you can see this is SSID and this is password. So basically, These two things are required to connect the board with the Wi-Fi, right? So that our device can access the internet. Now here you can see uh, this is the software serial port, right? Now this is RX, this is TX. So I have just used two different pins, 16 and pin number 17. So our Nucleo 144 board's UART is connected with these two pins only, pin number 16 and pin number 17. And pin number 16 is RX D2, pin number 17 is TX D2. So we have these two pins. Okay. Now here just we are creating web server. Okay. And to store the data, just we are using this structure. In this structure, you can see water quality data is in TDS value, pH value, turbidity, quality status, last update, and data valid. Right? These different values are there. 6, right? Types are also given. So this is the structure, and we will going to share this structure over the internet via web page. Okay, now this is the HTML web page. So you can see this is the simple HTML web page, and within the web page, you will simply send the data. So I'm not going deeper into this web page, but for your simplicity, this is the title. Okay, some icons are there, right? And here you can see this function fetch the data. It will fetch the data, right? It will also display this refresh data icon, right? And it will simply send the value, different values, TDS value, pH value, turbidity value, quality score, and last update, right? So we are simply sharing our data, okay, through the web page. Whenever user will open this web page, user can see this uh, whatever HTML code is written, right? And that is how real-time data can be monitored, and it will refresh it every 2 seconds. Okay. Now some functions are there: handle root, handle data, parse ATM2 data, connect to Wi-Fi, right? So different functions are defined, and program starts from here. So initially it will simply print different message on UART, ESP32 water quality, then baud rate, right? This is software serial port. So to initialize the baud rate, you have to write software serial dot begin. Here baud rate is there, right? Schema is there, how many bits are there, then TX RX pin, right? So it will display different messages. Initial value of all the sensor is 0, right? Now here this function will simply connect with the Wi-Fi. If I will just show you the function, you can see connected the Wi-Fi, and connect with the Wi-Fi, you have to simply write Wi-Fi dot begin and pass the SSID. So it will try to connect with the Wi-Fi, and once the status is equal to WL connect, so you can simply print this message that Wi-Fi is connected. So when this the Wi-Fi dot status will become is equal to WL connected, it means your Wi-Fi connection established, and you will see different messages over the UART. Okay, again this is for UART, right? So now once connection established, next what happen? It will simply set up web server router. This is route, okay, endpoint, and this is another endpoint. Get the data. Now here serial begin, serial print, access web page. This all message you will see over this uh, onboard UART. So serial means onboard UART. So here user can see the message for troubleshooting, and otherwise to receive the data over the pins we have software serial port. Okay. Now this is void loop. So here you can see handle the client's request, web server's handle web server request. So whenever client try to connect with this device, because once Wi-Fi is connected, you will see one address of this device also. And when user will connect, okay, you will see the message that user initiated some connections, user trying to access the web page. Okay, and here what is happening, you can see continuously on software serial port, it is receiving the data. Basically these data are coming from the STM32 board. Okay, so here we are simply displaying whatever data we are receiving from the STM32, and here also you can see continuously receive data from STM32, different values are received. receiving over the UART, right? And simply we are parsing the data. So once we have fixed the string, we will simply parse the data. That's it. Okay. And this is continuous process. Okay. And now let me show you parse STM functions. Yes, this is the function. So you can see it will simply check the index of TDS, index of pH, index of turbidity. It will connect into this integer variable, right? It will check some, it will extract the data from this. You can see data substring, data index of ppm, right? So it will extract all the message because our messages, you can see we are receiving same message from S nucleo 144 board. We are extracting TDS value, extracting pH value, extracting turbidity value, quality, timestamp, right? And we will display this same message over the URL. So you can see this message, right? So your past data is TDS, pH, turbidity, quality. So now once the data is ready, we can simply send this data over the internet via web page. That's it, right? So this is the how this it will handle the request. Okay, and here is the web page. So now once user will open the IP address, this web page will serve and continuously with interval of 2 seconds, this data will refreshed and provided over the web page, right? This one you can see, and this endpoint is data, right? So this is what the overall code. Now let me show you this setup first of all. So here you can see this is a Nucleo 144 board. This is ESP32 device. Okay, this device is connected via UART. These two pins you can see. So this is ESP32, and here three sensors are connected. You can see TDS, pH, turbidity. All sensors are connected with Nucleo 144, and Nucleo 144 send data over the UART to receive by this ESP32 and will serve over the internet using web page. So this is the overall setup. You know, number of connections are there. That's why it looks very complex. Otherwise, if you go through the block diagram, then it will be easy to understand you, right? This is the ESP32 board. Now, here you can see the terminal of our Arduino, or you can say ESP32. I'm just resetting this signal, and here you will see you observe different values, right? Initial message, the connecting to Wi-Fi, pin number this, and here you can see device connected with the Wi-Fi. Here you can see, and this is the IP address. You have to remember the IP address. Let me reset it again. Connected to Wi-Fi, and IP is 192.168.1.6, right? 192.168.1.6, and here you can see 192.168.1.6. Again, I am just opening the same IP, and here you can see we have that web page directly, okay, from the device. And here you can see these are real-time reading 26 seconds ago. Just refresh this and you will have exact value. So TDS is 247, pH is 9.76, and turbidity is 64. Now to demonstrate you, let me remove the TDS sensor. I'm removing it from the water. And you can see now TDS reduced. Okay. So this is the live setup, how we can send the data over the internet. Okay. And I will explain you this code in detail in next videos, but this time our focus is on how to share the data over the internet from our nucleo board, and that's why I am not uh, explain you this IoT code in much detail. Otherwise, this video will become very long. So this is what for today's video. If you like my work, this please like my video, subscribe my channel, share it with your friend. Till then, bye bye. Thanks a lot for watching the video.